Okay, 1:30 p.m. Our time here. We're going to go ahead and get started. Again, I am Josh Parent. I am the Tech Center and Training Manager for Podorf. With me today is Mr. Brent Farmer. If you don't know Brent Farmer, Brent is an application engineer on the Louver side for us. He is one of the best application engineers for Louvers on the planet, and I've worked with a bunch of them, so I can say that. Webinar Wednesday, thank you for joining us. If you have any questions during the presentation, please put them in the chat. We'll go ahead and answer those at the end of the presentation. You will be muted until the end, so handle chat accordingly. And beyond that, you will get PDH credits. If you put your name in the chat at the end, we'll take roll of those and get those out to you. We'll also do a Amazon, or I believe it's a Visa gift card now, a random giveaway at the end. So again, thank you for joining us. Look forward to a great presentation with Brent. And with that, I will kick it over to Mr. Brent Farmer. Brent.
Thanks, Josh. Hi, everyone. It's afternoon where you are. Good afternoon. Otherwise, good late morning. Like Josh said, I'm application engineer here at Podorf, specifically for Louvers. So I will often help with trainings like today and maybe any other technical questions in the background, sometimes assisting you in our customer service or our rep networks, engineers, anyone needing general questions answered for our louvers. So today we're going to talk about principles of louvers, or sometimes being known as just some louver basics here. We have quite a bit of material, so again, like Josh said, just put your name or put your questions down there in the comments. We'll circle back to them later, and I may run through some of these aspects kind of quickly, but just to give you a good overview about louvers today, there'll be a lot of information on the screen. I don't want to dive too deep into all of this because I do want to be wary of everyone's time. So without further ado, let's talk about some of the agenda today. The learning objectives, first and foremost, we're talking about the actual purpose of a louver. Why have it and how does it work? And then we'll jump into the louver design and construction and the most common louver types out there on the market. And then we'll finish out some of this with AMCA performance testing and louver finishes. So what the general purpose of a louver, what does it do? And really it is allow the air to flow into a building while you're going to keep any water and any other objects, primarily say like bugs or insects, out of your building. And we would also like it to blend into the general architecture of the building. Quite frankly, they are vents, well-designed vents. So talk about the general construction and the general design. The vast majority, you can see that you can have our louvers probably made out of two things that we're going to sell here is extruded aluminum or formed steel. I can tell you that the vast majority of the louvers on the market today and that we will sell are going to be extruded aluminum. Most commonly, those are made out of an alloy called 6063 T5, which is just an architectural type of alloy. It's what generally considered. And we can make it out of another type of alloy, 6063 T6. That's a little bit stronger, maybe sometimes for higher design load or any type of structural piece. The aluminum is, for one thing, it is lighter than a lot of your steel, but the way it can be heated up, we can actually get a lot of precise profiles. We can make some very interesting shapes out of it. You can start to see some on the screen. You're gonna see a lot more here later. But really what it is with technology these days, and it's been around for a bit, but it's really caught on, is they can, you can heat this aluminum up, and it's almost kind of like Play-Doh. They put it into a big cylinder, and they can push it out of a big metal die that has a fun shape cut into it, and they'll just pull very long sticks out of from whatever shape we would like and out of this aluminum. So it gives us a lot of flexibility in terms of what we want to do and what someone needs on their building. So some of the general components of a louver, I'll start with some of the frame pieces first. So starting at the top, you're going to have your head, right? Everything's going to have a head piece around the top of it, and it's going to connect the two long pieces on the sides, which are called the jambs, together to just kind of form start part of a frame. And at the bottom, you're going to have a sill, which is sort of the base, which might collect any water to help it run out, but also is just going to be something for the louver to sit on. And then in the interior of your louver, you're going to have a drip. I'll say probably 90 to over 99% of our louvers right now that we sell now have a drip on them. And what this really does is it acts as a gutter to catch any water that might be running down the face of a building from rain. And it'll collect a lot of that water before it can even get to some of the blades and push it down into our jams. Our jams usually have some type of channel in it. We like to call it a downspout, but a channel that will help carry that water all the way down into the sill and so it can run out of the louver without going out of the building. So increasing its performance there. The main thing you're going to see on every louver, of course, is the blade. Um, the number of blades is just going to depend on the how tall the louver is, or maybe just the general design. But we're going to vary in any type of shape, size, and angle, just depending on the purpose. So let's talk a bit more about how all the different types of louver blades and how they're going to be made, and what some of their purposes. So generally, you're going to have three types of louver blades. Stationary, and so all of these that you actually see on the screen right here are what would typically be like a stationary blade, but some of them can fit into other types. Here's operable and combination. Um, so the stationary blade is what we might call we might refer to it as just a blade that's just not going to be moving. It's going to be screwed into the jambs and they're just going to stay as they are. Again, it's just like a vent. Think like a vent there. Um, an operable louver or with an operable blades, the blade might have some part in the extrusion that's going to have some type of axle on it, and that's going to allow all of the blades to rotate. Uh, so they can go flat, as we sort of see. I'll say flat, but they'll be in a an open position, much like you'll see right here. And we can actually close them all up to where essentially you would not be able to see through it, or they might turn 90 degrees to where it might prevent airflow or even less water coming through. And finally, the last louver type we have is like a combination. And this is where you're going to have some type of fixed blade in front and a blade that can open and close, or operable blade right behind it, but it's all going to be enclosed in the same frame, and we'll show you some examples of that soon. Now each blade can have a different profile, and that's really what you're seeing mimicked on the side of the screen here. You can generally have drainable blades, uh, J blades, and K blades, which these days they're very similar, basically the same thing, and sometimes serve the same purpose as the industry has grown. Chevron blades, and these blades, we're going to jump into a bit more of your specialty type lures that are going to see lots of rainfall, potentially even like storms with lots of wind that might actually be pushing water into your building. And finally, and then you'll see for a lot of your stationary blades, you'll see a lot of, or you might see some inverted, like Y, what we call Y blades, as you see on the bottom there. It kind of looks like a Y, maybe even a V to some people. And that is going to be a stationary blade, but it will help keep it's like site proof. So you won't be able to see into the building with this blade. And lastly, sometimes you'll have airfoil blades. Airfoil blades were predominantly going to be on some type of operable or combination louver. Now, the blade angle is another aspect of each of these, and you generally have three angles here just based on the industry: 30 degrees, 37 degrees, or 45-degree blades. Uh, and those, again, we'll jump into that, but that predominantly helps with how much airflow you can get into a building. It's a good rule of thumb to base certain blades around. And lastly, we can have blades. They can have an orientation of either horizontal or vertical. Uh, most of your blades are going to be horizontally fixed into a louver, and some can be vertical. But again, those are going to be for sometimes a very specific purpose. Usually, you have a lot of rainfall coming into the building. And here's some good examples of some of those louver blade styles that you can see. These are all horizontals on the screen here. Um, Now, a lot of your J's, K's, the Y blades, those are called, we can also call that as a non-drainable louver. So as you have a blade style, sometimes we have a broader a broader category. We might say that's a non-drainable blade. And really what that means is based on the front orientation of that blade, the water's going to hit and kind of run off. Now, a drainable blade might have a pocket or a gutter in here, kind of like a drip. And it can also help to catch water and push it back to the downspouts there. Drainable and non-drainable blades are great for uh, exhaust applications. Drainable blades are going to be better for intake applications. Or yes, drainable blades will be better for intake applications as well. And what I mean by that is, your HVAC system is pulling in air versus blowing it out. The wind-driven rain, as we see, wind-driven rain louvers typically use the chevron. So instead of calling it a chevron louver, we'll call it wind-driven rain based on for what its purpose is. You can use it for intake or exhaust, but really what it is specifically designed for is to resist what we call wind-driven rain, and we'll discuss more on that soon. But that is a storm that is actually has lots of wind that might be, say 30 plus miles an hour that actually be pushing with a wind to it that is actually pushing rain into your building rather than just mostly kind of run a steady rainfall running off the front of the building. The blade angles that we have here, the general rule of thumb is, and what you can see on the screen as we just talked about, we have some J and K blades here. So these are non-drainable louvers. So again, would be great for exhaust applications. But say the lower the angle or the flatter the blade, it's a general rule of thumb that you're going to get like a better air performance. You're going to be able to move air through it better to get like kind of less resistance coming through. So you can sort of see what we have on the screen here. Like for example, a 30 degree blade angle is probably going to have a high free area or a lot of free space for air to move. So it's going to have like a lower pressure drop. It's going to it's going to resist less air movement less. But you might have more blades in that. Again, that's so that you don't have really large gaps to see through. So as you can see on the right there, you're going to have more blades in it compared to a 445, but potentially have some better air performance. Here we're jumping back onto, again, this is a good example sort of our jams that we have as we were discussing the drip integrated, and we have that downspout in the jam as well. As you can see, any type of water coming down a building might be caught in this gutter here and pushed down into this downspout, whereas here, this isn't going to catch anything. Water's going to roll right off and hit the blades. And again, if your system is bringing in air, potentially that water could get sucked into your duct or to your opening. So some of our typical features of a frame, obviously, as we have a non-drainable or drainable frame, I can tell you that more and more, or most of our louvers on the market and more louvers across the market from many manufacturers are moving more to that drainable type of blade or frame. It just generally performs better. So more people are incorporating it into their designs. We do offer other options for sometimes based on your building type or aesthetics that you might need. So look at it, we have flange options, and these might go around the outside off on the frame, sticking off the frame. Here's a good, here on my screen is a good example of a flange frame that you can see from a cross section of a louver we have. And that's just going to be something that's 1.5 inches. It might stick out all the way around the frame. And sometimes what people might want that for, is an architect wants it, something like that, is to maybe hide uh, where the opening meets with the louver frame itself. They maybe want that hidden a bit. It sort of is a little bit more of a seamless integration with the building sometimes. Uh, a glazing frame, if you're not aware what a glazing frame is, what we're talking about there is we will do another similar add-ons like this flange. It'll be a small channel, and that allows our louvers to actually set in some type of window glazing or like window mullions for a curtain wall. So they can be incorporated into what those are usually aluminum extrusions as well. So again, if you have a large curtain wall, sometimes you might need airflow through it, but we can actually fasten to that. Lastly, stucco flange. You don't see this as often, but certain buildings that do have a stucco exterior, we will have a small flange, but it'll be a little more inset. So as the louver gets set into the opening, that flange will sort of stop it on the, say like a wood, wood framing there, and that will allow whoever the contractor that is maybe putting the stucco finish on the building to come around and make sort of a seamless integration with the outside, with the face of the louver. So quickly here, touching up on mullions, and mullion is what we're going to call, is maybe where two of our jambs come together to make a window, like a mullion look there. Again, think like a window mullion if you've heard that phrase before. So we will typically have visible mullions from what you can see over here. You can see two louvers. We have a left and a right jamb, two louvers being set up there. And sometimes rather than having a big line down the middle, an architect would like that to just be one space. So what we can do is somewhere we can have an extra added piece that we can slide in the middle of two of the, or they'll go in between these, that an installer can use, and it'll kind of make a little bit more of a seamless integration there. And or we can actually usually give the option of what we call a hidden mullion. And this is where a lot of the times where an architect wants a continuous blade look, maybe some really long, they're using some opening more, maybe more architecturally than mechanically, and they really need a continuous look. We can actually use some angles in the back there to create that. Here's some good pictures of our glazing frame actually right here. This little channel piece, we can see a cutout here and a cutout here. The tan pieces being some curtain wall that another manufacturer has, and they can actually set our louvers inside of it. Just touched on some of our mullions that we just had here. Is a good back view of how we're going to put these on the back, and will help brace these blades up to keep them sturdy. And these are great examples right here of those visible mullions on the top left here, and concealed mullions on the bottom right. This is a great, so you can see actually it I guess you could say in person, but actually being used on a building or something here. So the visible mullions, as you can see, let's say we have two louvers right here in each of these openings where you can see the jambs inset, or again, some architect wanted right here. It keeps a nice continuous look. So let's talk about the different types of louvers. We kind of just broke down some of the construction, maybe some of the blades, the frame pieces like that. And then I was mentioning sort of a non-drainable, a drainable type, a wind and rain type. Let's go into some of the what we'll call the broader categories, especially you'll see this on our website as to how we're going to break these down. So starting off with non-drainable louvers, this is really this is probably one of the most basic louver that you'll see right here. Best suited for exhaust applications where you're going to have water entering the building isn't the highest concern usually. Um, so again, with this blade here, you're going to see that it doesn't really have much ability to keep water or channel it or move it away from the building. So as water comes down the building, which is most common, you're going to see it just sort of drain down. And each time if water is maybe being pulled in or not being pushed out enough, it can drip back. We'll have a quick video that can kind of show us. We'll kind of show some simulation here. And really, Josh actually here, he does have lots of experience, um, various jobs in the industry, but one of those actually was doing a lot of testing at AMCA. And you can say, and we can probably say that what we'll see typically is the taller the louver, the the better, I'll say the better chance of getting water into the building is, and predominantly it's because the bottom blades are starting to catch a lot of water cascading down the further you go. Um, so we will so if water intrusion is maybe has some concern for you, we would typically recommend maybe a drainable louver if you want to get a slight step up. And really what that is as water comes down the building, what you can see right here is the gutter is going to catch the, I'll say the overwhelming majority of the water running off the building and channel it uh, into the jam downspouts or the channels there. Likewise, as any water might splash down onto the blades or maybe be brought in from falling down through the air, if some of it does channel down, it will also still have a gutter the gutter can channel it back to the jams as well. So, and like I said, these, as you can see on the screen, these typically do outperform non-drainables. And I would say that's a vast majority of the time that these will outperform them. Okay, so wind-driven rain louvers, and we will discuss a little bit more in depth when we get to some of the performance testing of really what does wind-driven rain mean. And as I mentioned before, it really is think of a storm with high winds that is going to be blowing water in. So the chevron blade, just as you can see, it has a much tighter blade spacing. It will be site-proof, which is a plus. Sometimes at a higher cost due to all the material there, but due to that profile itself, as a blade comes down, that hook on the top there, it's kind of located like it's going to be in the middle of the louver. That's going to catch much more water than the other two types we just discussed. You see this, and so what we're kind of trying to show is this water is not really coming down vertically, it's coming down, has a bit of a horizontal component to it, right? That's actually getting pushed into the louver itself. So you need something to catch all of that water. So we do have a couple different models here. These can be used for intake. They can be used for intake and exhaust. But your biggest concern here really is preventing water from getting into the building, and particularly in some type of room that is going to have some type of specialized equipment, or maybe let's say very sensitive equipment. What you can see on there is some examples of like a generator room or an electrical switchgear room, something that's going to be very necessary for the building to keep performing. Or you could potentially have something that maybe does have people in that as well. But the tight blade spacing on these really does prevent a lot of water intrusion. The vertical blades on it, I can tell you, vertical blades are going to be the best performing blades at keeping water out of your opening or your ductwork that you can buy from a louver. And that is just because as water maybe gets blown in or sucked in, if it catches any type of channel or blade, it's going to follow that blade all the way. It's going to be directed down to the base of that sill and run out the louver there. So those were your stationary types there, your non-drainable, drainable, and the wind-driven rain. Now, a lot of that same concept, other than a vertical louver, but that same drainable blade and non-drainable blade, those can be carried right into our operable and combination louvers. Again, remember that operable or combination has at least one blade on it that is sort of moving or rotating about itself. So in an operable blade, the entire blade pivots are closed. And I want to highlight right here in this, the third from the left is this EOJ 637. As you can see, this blade down here, say the bottom one is what these are open positions. And the dotted lines here are going to show it as it's in a closed position. And what we do is we'll have some type of handles with some linkage on it that's going to be able to rotate all the blades at once. That can be either hand operated, or we do sell actuators with that, just similar to many of the actuators that we might offer for louvers are going to be available on our damper line as well. The operable blades usually are not as high performing as some of our combination blades, but again, they might have a better architectural look to it sometimes. The combination louver, this is great louver for someone that is needing, again, a louver on the face of your building that needs to say have some type of finish on it to be able to blend in with the architecture of the building. You're also going to catch water with it, but you might be needing a control damper on the back, some way to again control the air, how much airflow you have, or the pressure coming into your building. So the combination louver, what it essentially does is it's going to be your louver in front and a combination damper, say right behind it, but it's all going to be in one frame. So it's going to really, it might save you a lot of money, or you could be something where space is really tight, say hooking up to some duct work or something like that. Or you could have a warehouse building where you might want to open these up, say in warmer months, and maybe close them in colder months where you maybe have some heaters going in a warehouse or factory setting. So some options there. We do even have, this is still considered an operable louver, but what we call kind of a integral, like a backdraft. So if you're familiar with backdraft dampers, right? Say you're blowing air out of this, these blades are going to be, say, laying down, and then, gravity just kind of pulls them down. They're just free swinging, and then it's going to push this open as you push air out of it, but it won't allow air to come in. And we have the vice versa of that as well. We have one where it'll only let you bring air in, but not push air out. So that about covers the different types of louvers that we will offer. Moving into some installation, and we're just going to get into some basic installation here. Our louvers, typically we fasten them with what you call like a clip angle, just a small L bracket, or again an angle that's made out of aluminum, and we will usually supply, if you order from us, we'll supply screws or some tech screws to maybe sheet metal screws that allow you to fasten the clip to the louver itself, and then you have an anchor into the building condition. Here's good views of a standard installation here. What we'll typically do, as if you're ordering one of our louvers, you typically put in the opening size that you might have, like that be on the building, and we will shrink the louver by about a 1/2 inch each way. So like width will shrink by a 1/2 inch, and height will shrink by a 1/2 inch, and that just gives the installer plenty of flexibility when they're putting the louver into the opening, right? As we've seen sometimes or heard from, as these buildings are getting built out, an opening may not be 100% square, or it may not be always, 60 inches tall on one side and 60 and a quarter on the other. So installers need a little bit of space as that goes, but they can put this into the opening, and then we'll see on the back side. So we give these are all available on our website. This is actually in a PDF on how to space the clip angles and how to fasten them once it's in the opening there. And we do require people to caulk or seal between the louver and the building finish. Again, that's just any water that's running down the building or any rain that's coming, out from the sky hitting this. You don't want that entering into your building, especially if you have some type of wood connection, right? We don't want that exposed and any type of rotting. So we will ask, we do require installers to maybe put, if it's a larger gap, maybe put some type of backer rod, but some type of sealant over that to protect the louver and the building and protect any water from getting inside that opening. Okay, so performance testing. I'm not sure everyone's position here. what your title or your role may be as you're watching this. Um, the performance testing, some of you, we'll do a quick overview. I won't dive too far into maybe some of the numbers necessary, but just know that the performance testing is there predominantly is a couple of things here. It's to help people compare louvers from different manufacturers across the industry, but also to help, your engineers or anyone trying to meet a building specification for, what is the system maybe pulling, or what does my buildings need, is how much water. And all the performance testing does is it really gives people just some quantitative data to be able to figure it out. So as we've looked at this, quite simply, louvers are vents. They really just need to keep water out as well as other objects. But now we kind of get into further down into, say, the weeds is how well does a louver do those things? And one of the largest entities, or the main entity in North America, is AMCA's Air Movement and Control Association, and they will handle a lot of the standards and the testing for performance of a louver. Um, you might be familiar with them. You probably heard about them. They do a lot of work with, commercial fans as well, sometimes exhaust fans, other types of fans at that. Well, they do handle louvers and dampers also. The main standard that they have handling louvers is AMCA 500L, as you can see on your screen up here. And that 500L lays out the kind of the base testing for these four key areas of a louver, the kind of some of the key performance features, and that's the free area, the pressure loss, or what they call air performance, the water penetration, which we've kind of been discussing as to water moving down a building, and then wind-driven rain. They do have two other main standards dealing with louvers, and that is AMCA 540 and AMCA 550. And those two standards are predominantly what we call severe weather louvers. Now, as we were talking about wind-driven rain, I'm saying that's more of your storms, your higher, your more severe storms. We won't always consider wind-driven rain like a severe weather, but severe weather in this case, let's just think of it like a hurricane, pretty much, where you're gonna have extremely high winds. You have lots of water, but that water is being blown about by these high winds, and you might even have debris flying through the air. That is obviously a danger to the building, obviously with people as well. So we were trying to protect the occupants inside a building from a hurricane. And I'll briefly touch on what those are here and how some of those tests are. We have some videos that you'll get to see here soon. But AMCA, as you're going through these and you kind of want to know, well, what do these numbers mean? How do I look them up? AMCA, if you see any of these three seals or these, like I call them kind of images on someone's catalog page or on their like submittal sheet for a louver there, then what you can know is that AMCA actually does have, as it says, AMCA certified ratings. AMCA has actually looked at the test data, or they've done it themselves, and they are verifying that that louver does check out for these values or this data being listed for this louver. So let's dive into each one of those that we just saw up here, this free area, pressure loss, water penetration, and later we'll get into this impact resistance and high velocity wind-driven rain, which is again essentially a hurricane. So the free area. What is free area? And this you might have seen on a building specification, or you might have been trying to meet a spec before that has this, some minimum free area for a louver on it. And what it really is this is a good representation right here on the screen is, if this is opening, let's say this is 5 feet wide by 5 feet wide. If the air can completely move through it, this 100% of this air is free to move through. It's not obstructed. Now, when you put a louver in it, as you have the frame, mostly the blades, that air can't move through. It is going to hit some of those components. So how much of that area is just free for air to move through, right? What is that in square feet? What's the percentage of this opening that's free? Well, AMCA does have a way, and it's actually in that 500L standard. This is an image from there, and here's the formula they have come up with to how to measure a louver for determining that free area in square footage, and they also have it in a percentage as well. Because sometimes you'll see percentage thrown on the building spec. Um, again, if you see something that has one of these certified ratings where they have looked at that free area, they have verified that as well. And often on a lot of charts, you will see this is to usually help people when they're specifying, whatever size louvers they have. They can look at it in width and height, and they can quickly kind of determine. They can have a good table to figure out. This is pretty common across in the industry here. This right here, this is the free area velocity in feet per minute. And we'll use this as this is really what it is the volume of air that say an HVAC system is pulling, like in CFM. That's going to be a common thing that engineers are going to be dealing with is the volume of air. And if you're pulling that over a certain area that's open or free, we're going to get what we call a free a speed in feet per minute that can be used later, and we'll figure out for some pressure drop here. I'm going to come back to that slide in just a second, but I want to hit on pressure drop since we just touched on this. Pressure drop is sort of the next step past free area, and I will say that pressure drop is probably not talked about enough when specifying a louver for a building spec. It is an extremely important component of a louver, right? Up till now, we've really been talking about keeping water out. But really too is you're wanting air to flow across this, and usually an engineer or type of architect they need a certain amount of airflow to get into the building for that building to perform and be comfortable in, right? So pressure drop is really you want a lower pressure drop number, the better. A higher pressure drop means, right, you're going to have more pressure right behind that louver. So as we can call it up here is the difference in air pressure across the louver. It's due to the friction of air moving through the unit. And really just think about it as I heard one time as a good example of if you were driving down the road and you had put your hand out the window, you're feeling the wind against that, you're feeling some type of pressure against your hand, and right behind it, you're probably not feeling anything pushing, behind your hand, but you're feeling everything in front. So think about the higher the pressure, if that's a louver, the higher the pressure you're feeling on the front of that and you're feeling nothing behind it, that HVAC system is going to be having to work pretty hard to pull in air to then push it into the building. So AMCA, they will test for this. They will predominantly put this up into like some type of air chamber, and then they'll pull air across it at different speeds and then basically mark and measure those speeds. What you can see on the top right of the screen here is a nice graph from that free area velocity that we just talked about. So they'll take the free area that they measure, they'll pull certain CFM and figure that free area velocity, and then they'll mark the pressure drop as we see it there. And this is a great tool for engineers, especially should be needing to know this. I'll jump back up into this slide is touch on this real quick. This is called our list program. This is Podorf List. It's sort of a software that we have actually on our website. You don't have to go download it. It is available just on our website under, we should have some menus up top with some selection tools there. And here you can actually select all different aspects that you might need, whether you want an aluminum louver, do you want a certain depth with it being like a 6-inch deep or a 4-inch deep. So now you can select your blade preference. You don't have to, a different type. And you can even put in certain performance criteria. So if you're someone you still feel like you're learning what all of the different, if I've been given someone's needing this amount of volume air, certain CFM, and I just need to know, is water going to get in here or not? Or I have a large size that's maybe not covered, or I see this free area and I just need to know, is this going to work with some of this information I've been given, or I have some of these certifications or standards that I need to know. If you have these checked out with AMCA, we have this selection criteria available to you. And it's like, for instance, with some of the things that have been set up on this page, you can see that at least we have two louvers meeting some of this exact criteria here. So I would highly recommend you use this tool available to you. We even have another feature in here on a product schedule. So let's say you find a louver you want, you can click the plus sign up here to add, and it's going to add it to a louver schedule for you. So if you're working on a building that has, let's say, 10 different openings, or even just 5 different openings, different louvers, just keep adding them to your schedule, and you can actually export that to yourself as, I think, either as an Excel file or a CSV, and that you can save that louver schedule for you. Okay, so water penetration. We've been talking about water getting in the building, and then we've been talking about water penetration. You may be just thinking, like, what does that really mean? And in AMCA's terms, water penetration, what it really is it is the point, or let's say the speed that which you're pulling water into the building. And what they'll generally do with the test is they'll just have a fan pulling air in, and you have say a general rainfall, and at what speed of air pulling across the louver is water going to start to get into the building. So what speed will water start to get into the building? And as you can see on this little graph here, as we can see that this louver probably had 1,250 feet per minute that we're starting to get water in. And the magical number that AMCA tries to test for is this, 0.01 ounces per square foot of water. And what they'll literally do is they will go into a chamber here, and they will walk into the chamber after the test is done, after pulling a certain amount of after a certain speed, and they will walk in and they will wipe any water up, and measure a paper towel. And if it measures than what it was with the dry weight, they say, hey, you have some water in now. This is the beginning point. And it will give a little video here, as you can start to see. This is a bit older video, but the test really hasn't changed too much. You can see water kind of simulated running down a building, and some nozzles at top, even they're dripping water. You can see it dripping, and then water running over the face. This is a little bit older louver, but that fan is pulling water in. You can actually see some cascading. Here's the fan on. And this is an interior shot of the louver, so you can see water being pulled in. It's being sucked in right there. And so the last main test in the AMCA 500L is a wind-driven rain. So what I'll say is water penetration wasn't quite pass-fail, but that's kind of a pass-fail test. Really, you're just wanting to know what speed it is, but once you hit that speed, anything over that, you can say, hey, you're going to fail. Your water is going to start to enter your building. Sometimes when you have a building, depending on the application or depending on where you are in the country, you're going to have storms that actually might have some wind with them, and they're going to be pushing rain in. Now, with the wind-driven rain test, the main test is the purpose of the test is to test the louver's ability to prevent water from infiltrating during these conditions. So it's not a pass-fail. What it really does is it's going to give you percentages on how much water how effective was it at keeping water out of the building. So as you can see on here, the effectiveness, and you can see some of the percentages listed out in a class. Now on a lot of the catalog pages that AMCA will approve, you will You will see this class, the effectiveness. You will see the percentage listed. I can also say that to help you, you will see a wind speed given. So you might see like a 20 mile an hour. You might see like a 50 mile an hour wind speed, and you can see a rainfall rate. And you probably will see a total amount of water that, or some certain amount of water that was dropped off that. So you can see how effective was this with this wind speed, with this louver at keeping this amount of water out of the building. So I know that some water is going to get in, but really, is this louver going to keep out, 99% of that? I can, an engineer might say, my equipment will be safe. I can live with that. Again, here's some of the bit of that chevron blade here. These are going to be the most effective. Here's some images actually of AMCA and their setup. We'll have a video right here, so this will give you a better view of what this is doing. This is a large fan right here. They're actually going to start this and blow water. You start that fan, and here's some nozzles coming out. It's actually spraying horizontally, and that fan is going to be pushing water directly at the face of that louver. Start some of this again real quick. So you can see it as each nozzle kind of clicks on and off, but it keeps spraying over a certain number of minutes. And then they will measure at the end of that is how much water got in. Okay, so that was 500L. So there's some of your basic testing here. Stop real quick. We have about 15 minutes, so it should be doing well on time. Now is going to have more. We're going to talk about your hurricane testing. What this discussed earlier was your severe weather louver, and AMCA is going to help test with that. You also see two others. If you're not aware of this, you can see two other, I'll say, entities that give out certifications. The main one is going to be Miami-Dade County itself. They have a lot of they have many tests for their actual own building code that certain local jurisdictions have adopted, particularly on the East Coast and throughout the Gulf Coast as well. And the Florida Building Commission, I can't tell you that the Florida Building Commission or Florida Building Code, it basically does adopt a lot of the Miami-Dade standards. Miami-Dade back in the mid 90s, I believe, was hit by Hurricane Andrew, I believe it was, and I can't remember the dollar amount of destruction that it caused throughout the city itself, but it was a very devastating hurricane. Since then, Miami-Dade County has come up with a lot of adapted their building code for certain standards for their buildings to resist hurricanes. And one of those is obviously louvers are being on the outside or the envelope of the building. We do have set of standards that Miami-Dade does want you to follow to be able to sell in Miami-Dade City or in Miami-Dade County. And like I said, many other jurisdictions have adopted that as well. So sometimes to be able to sell in some of these areas, or to be able to, if a building code does have a Miami-Dade adopted standard, to be able to put in a louver in some of these buildings, you will have to have it approved by the Miami-Dade County. They have a notice of acceptance, like what we call an NOA, that we have to follow, and they will have to see test records of some of the louvers that will be approved by them. AMCA as well, that 540 and that 550, that tends to usually go hand in hand with some of the Miami-Dade standards. So the Miami-Dade standards, I'll quickly talk about them. You have to have an NOA to be able to sell, or to be able to be approved by Miami-Dade County. And they have 3 tests, typically called TAS 201, 202, and 203. They do accept AMCA 540 and 550 as alternates. So again, the 540, I'll quickly go through the 540. That's a missile impact. So again, that's talking about flying debris. So as this hurricane winds are ramping up, let's say they have anywhere from, I'll say, low end of obviously like a 35 mile an hour. That's a pretty low end hurricane. And then, you say you could see, or you see wind speeds well over 100 miles an hour. Well, within that, you do see, as you watch any like the news cycles before, you see debris sometimes going through the air with that. So the 540 or the TS 201, what we test for is flying debris, so impact. And what you're going to do is you actually put a 2x4 that's 9 pounds into an air cannon, and you will shoot it at the louver. Now, if any of the blades come completely apart from the jambs or the heads, if they allow the 2x4 to go through the louver, you will fail the test. Uh, and the TAS 202 and 203, that's not necessarily for impact, but that is essentially covers the high winds that are going to be there. So sometimes the wind itself could put a very high pressure on a louver, particularly think if this louver is the higher up on a building it goes, it could potentially see more wind. So what they'll do there, we'll watch a video on this soon, is they will put some type of film over the top of the louver, and they will suck that against the louver and sometimes even blow it out. So if you almost had like, air sucking uh, or wind sucking air out of the building or pushing against the louver, and they will test for any type of the structural failure in the louver there. So again, on if you see some type of Miami-Dade approval on a catalog page, then you know that whatever design load gets listed on that louver has been approved by Miami-Dade. The TS 203, that's a very similar one. Those two pressure tests, they're just one is cyclical. They just kind of they suck air in, they let it out, they do it over, they repeat. And versus 202 is just one pressure, just one pull. Now, TS 100, but predominantly is AMCA 550, and that is the high velocity wind driven rain. And that is where, again, where you're talking about, we're going to shoot rain at up to like 110 miles an hour at this louver. And that test is a pass or fail. You're going to get some water into your louver, and it's how much after a certain gallons there. The Miami-Dade rain testing, again, that's mostly 550. As we see here, not all Miami-Dade louvers are wind-driven rain resistant. That's a good thing to note. We would look for AMCA 550 rating listed, and that would be, we might see some type of tag, such as this down here, that might actually list some of those ratings off. It might actually list some of the ratings there. But you can have a Miami-Dade rated louver for pressure, essentially, and impact. Miami-Dade installations, just real quick, Miami-Dade installations are, if you have a louver that is approved for some type of severe duty, severe weather, then we will have more of those listed predominantly. When I was going over installations earlier, I didn't discuss anchors. We do not typically sell the anchors, but we will specify them if it is through Miami-Dade. Miami-Dade does, to get the NOA, they will at least need to see that you have done calculations for, maybe by a professional engineer, and have them stamped. And they will review those as well, depending on the building condition, that they need to see some type of anchor being approved and at least shown to an installer. Here, let's take a look at a few videos over some of those tests I just talked about for any of these Miami-Dade or any of these AMCA 540, 550, these severe weather. So this first one is that air cannon. This is always usually a fun one to watch or participate in, unless you hopefully don't have a failure, but it is fun to witness nonetheless. So you can see the air cannon here on the left. You can see a long tube that will have the 9-pound 2x4 in it. And the red dot here is exactly where they're aiming for on this louver. So there we go. It's quick tests. It's not a far distance at it. That 2x4 does bounce back. You're going to shoot it, typically, you're going to shoot this at least 3 times. You'll shoot one towards the corner, one in the middle, and one towards the other corner. So they're trying to check multiple spots on this so that you can't have any type of failure. Here, this one is exciting, but what we'll see here is this is that bucket test. This is a fan ramping up. It's difficult to see, but that bag actually is pulling that louver in towards that wall right now. You can start to see it, the bag tightening, and those jams, this louver is deflecting. Usually, like they'll do this to 150% of whatever that load is. So if someone said this louver is good for 150 PSF, they are testing this one right now at is it 225, I believe. And there the blower's letting go. So, and they have strain gauges right here to measure how far does that pull in, that jam pull in. This one isn't as exciting, but that 550, this high velocity wind drill ring, again, this is the hurricane, like the water at a hurricane test. Here you can see water spraying. You're going to have the louver in this wall here, some type of collection chamber. It's open in the back so air can actually flow out. Remember that from that pressure drop, if you have less pressure, air can move through it, which is good for this test. They will actually usually just measure this with a bucket, but they can weigh how much water is in there, tell it how many in gallons. But these speeds get very high. You'll actually see this. They actually usually use a fan boat motor. Most of the testing applications need a fan boat motor to get it. And you can see all of the mist as this just hits the louver so hard it just missed over the side here. That 550 test, we can see here's just some ways that it goes through just some of the specifications as they run. This is just how the intervals at the speeds they run at. They run 35, 70, 90, and 110. And they throw, they typically throw like 230 gallons roughly at it. And if you get 1% into the bucket over that entire test, your louver does fail. So very good at keeping water out. Lastly, let's wrap this up with louver finishes. We're almost done here, and I know I have a few minutes before we hit 2:30, and I know we want to give Josh and Kelsey some time here to get that gift card winner out. So I'll just touch quickly on our finishes here. We offer a couple different types: mill, prime coat, powder coat, wet paint, and anodizing. Mill finish is just we're not going to paint it. You will get the standard color, the raw aluminum. There is one, sometimes this can actually be a cost saving measure. It can, one downside is having no paint or coating on there. This louver is more susceptible to rust quickly. Then painted, other types of painted finishes, we do offer a prime coat. I can tell you that our sales guys will typically try to steer people away from prime coat. It's not recommended just because you're going to need to paint it afterwards. But if this ever goes to a job site and sits out there for a while, it will need to be re-cleaned and cleaned properly for any type of field application. So painting out after it's installed to match the exterior, it'll need to be cleaned before then. If it's not cleaned properly, paint will not adhere well. However, it can be ordered, and if it's done properly, it can be done well. The predominantly though, we'll do a lot of powder coat finishing. Many of you are probably aware of how powder coating works. I won't describe it all here, but we do get can be a bit more cost saving than some type of wet paint. It does have it still has a good warranty on the lifespan of that paint as well. And quite often some of these can meet maybe some of the green initiatives that might be on a building. Sometimes we start to see more and more of those, but it does have a long lifespan on those finishes. We can do a polyester or a fluoropolymer as well. And the fluoropolymer does have a better color retention and will have a better weather resistance. I can say that as long as a better, so it'll have a longer warranty with it as well. Um, it does not have as many options for color matching, or it could be a bit more difficult for some of our powder coating vendor to sometimes do lots of custom color matches. But to my knowledge, they still have a fairly good array of standard colors out there. Painted finishes, so any type of wet applied paint. We can do some in-house, but a lot of it we will send out to other vendors. These, I can tell you that wet paint is probably going to give you the best type of color on a louver that of all the types of finishes that you could get. It's going to have great weather resistance as well, and you're going to get all three types of coatings. So you're going to get a prime coat, you're going to wet coat, and you're going to get that nice gloss coat that's really going to give a good sheen or shine for the architectural look of this. Um, Again, there might be a bit of a cost associated with that, and maybe a little bit of a lead time as we send that out, but nonetheless. Anodizing, we do see this quite often. Again, I won't go through the anodizing process here. I'm trying to uh, keep us on time as much as possible. We're only going to do that for aluminum only, not as much. None of our steel louvers are going to get that. And if you're not aware of what anodizing is, though, we're just going to put a quick layer of that color pigment into the metal itself. But it can give you a great color if done properly. However, I can tell you that any certain alloys are going to hold that anodize differently. So if you want a colored anodize, a six structural alloy isn't going to look the same as an architectural alloy. It's just how those, because you're putting it on how all those molecules within the aluminum itself is going to hold that. Um, we can do a clear anodize, and it should give it some sheen there, but you can also do a colored as well. Obviously, it is more expensive. It's going to be in the tank longer. It's just a slightly longer process. Um, from what I've been told, the anodizing process is the darker colors are going to look better than any of the lighter colors. So your champagne is going to be the lightest color that you can have, all the way up to a black. And from what I've understood, the black might hold some of that color better than some of the champagne. But again, this can actually give you it can have a great weather resistance for holding up that anodized paint. So a good longevity on these type of applications for in your field. We do offer an alternative though to anodizing if you're needing something on the lighter end of that color. And we will call that like a pearl paint here. We can do that in-house. It is a competitive price. It's fluoropolymer though, but we can get a more consistent color. Again, think about if you had a louver or any type of architectural product that had some type of welding on it, or maybe you wanted to add some different alloys, we might recommend you go with the pearl paint. It's going to be much more consistent longer though. So and we can actually get a longer finish than some of the anodizing, particularly if you're doing on the light end of anodizing. So thank you again, fishing up right here just a little after 2:30. So right now, if we have any comments left over, then
Hey Brent,
we
there
can
was
talk
just
about.
one question in chat, and I answered it while you were doing your thing. Can you just take a look at that one and see if you agree? It's about adding the pressure, how pressure drop increases as you add screen to a louver, and it's really difficult to answer right because every different screen louver combination has a different pressure drop. But see if you have any comment on that one.
Yeah, Joe, that's a great question. So, okay, yeah, does the pressure drop listed include the pressure drop through a screen? If not, how much does it add? That's an excellent question. I can tell you that through AMCA, you, we do not, none of the louvers tested at AMCA will have the pressure drop on a screen. And the one sort of the workaround, I don't want to call it a workaround, but the basis of thought there is that, and make sure we're coming around this with Josh Josh's answer here, but it to go off of what Josh is saying here with it has we don't have any add-on or finishes. So yeah, if people do use different screens, that could affect how a louver is going to act. However, the general thought is that the screen has a higher free area than the louver itself, so it won't be as it won't restrict your airflow as much as the louver itself. Now, I can tell you that it will affect your pressure drop, uh, but it's it's not as much as you're quite thinking, if that
I,
if that makes sense.
I had heard, and this has been a long time. I've been in the industry since 2001, and there were a couple of different tech specs out there on it. But I had actually heard there's maybe one or two lure types where it's not really bad, but I had heard that it actually on most lures it was not really good, and I heard it was at 20% or more. But it's everybody has kind of their, everybody in the industry kind of has their own version of that. And I think actually there's one of our competitors that has a pretty good document on it. They did a lot of the internal lab testing, and
Mhm.
we all kind of use those same numbers. But I thought just to be, from what I remember, just to be careful, you want to use at least a 20% ad for a bird screen.
It is a good ad. No, now 20% over again, it does depend on the louver itself. If one does have an extremely low pressure drop, it will heighten it it could heighten it, but you still might have great, great numbers still coming out. Just to say, oh, it's 20% seems like a lot, but it it's hard. I can't tell you if it's quantifies. It does depend on the louver. So
I think it
it
was
it's
more. I think it was more just trying to keep people in. Take advantage of almost a safety factor. So
mhm.
yeah,
Yes, and I would say I think most of the time an engineer, if they see that pressure drop, they should be building in some type of safety factor for it
agreed.
as well. No, that is an excellent question. The one thing I will leave us with, or well, based on that, I will tell everyone I didn't touch on it much, but sometimes you see free area put into specs or it put into a building spec, and if you if you do get to where you are maybe having difficulty, matching up to another manufacturer based on one lure that has a higher free area, see how the pressure drop actually works. Sometimes over uh, across certain manufacturers, you like to go with the bird screen. You might even have the same bird screen, and one has a higher free area, yet somehow a lower pressure drop. And see if you can actually argue that the louver with the lower pressure drop should be the one that should be selected.
Yep, agree completely. Thank you, Brent. And now, if nobody has any other questions, I know we were kind of holding you guys hostage here a little bit after. We apologize for that, but we really appreciate you joining that. We are going to do our giveaway now. And with that, I'm going to turn it over to Kelsey. Kelsey, take us home.
All right, good afternoon, everyone. I'm Kelsey Fliginger. I'm the marketing associate for Potter. I'll be pulling a name for the gift card drawing. And for those of you who would like to claim your PDH credit, if you haven't already, please identify yourselves in the chat so we can send you your certificates. And with that, thank you all for attending. We can't wait to see you at our next webinar.